Alright, here's the Beta Laser Mic LaserSpeed Laser Non-Contact Encoder. On the right you have the PC software, it's called LaserTrak. In the center you have the laser non-contact encoder, and then on the left you see just a belt sander that I can move the product where the laser beam is hitting. So, and then you see a display right here that you can only use when you're not using the PC software. And then a power supply breakout module that you can get all your encoder pulses out of by wiring into the proper pinouts, as well as shutter controls and stuff like that. It's ran off of a 24-volt power supply, 110 power, 25 pin cable, goes to the LaserSpeed itself, and the 9-pin cable goes to the PC software, as well as a 9-pin cable which has power supply to it as well, will go to this device, the DataPro 700. So how the LaserSpeed works is I can move the cable, I'm sorry, the sander, and you can see the red line there where it actually, you can see the product moving. So that's in the forward direction. I just moved it again. I will turn it on. You can see how the speed ramps up and then held constant while I had it running, and then goes down back to 0 speed. So that is how the LaserSpeed works. It's non-contact, doesn't slip, doesn't wear, doesn't need calibration. It is a NIST traceable standard for calibration. So the idea is it measures a product directly. 2 laser beams come out to get to the focal distance. This is 300 millimeter standoff. You have plus or minus about 3/4 inch depth of field, so almost inch and a half depth of field that your product can wander in. You can mount it off these 4 bolts. Usually it's facing in a downward direction, and your material is moving this fashion, but it doesn't matter which way. It would be upside down, sideways, left, right. You can see it'll give you the length and footage, speed, quality factor, which shows you how good it's measuring, average, your velocity, your max and the min, valid measurements, material presence, items like that. Now if I turn it back on again, you're going to see the speed. You can see how the speed ramps up again, and now the velocity is back down to 0. As well as you can see the velocity here. Quality factor, so if I put my hand in front of the laser beam like this, you can see that the quality factor goes away, and that's showing you bad measurements. So now if you want to change any settings on here, the under LaserSpeed, LaserSpeed configurations is where all the configurations are basically done. Internal material presence is just, sometimes you can use external material presence. That's not the main thing. So the main thing I want to show you is this is where you change your speed, your pulse rate. So you have 2 channels of pulse rates coming out of the 9000 series, and right now they're set to 1000 pulses per foot. That's the basic standard coming out of the factory. So here's where we can switch feet to minutes, to inches per minute, yards per minute, etc. And so that will set your encoder pulses to match up to what your desired need is. Now if you can, I would make your control so it's 1000 pulses per foot per minute. That way it's just straight out of the box. This will change your operation. So in this one, the LaserSpeed 9000 can tell forward and reverse. So if the speed was coming down this way in a negative direction, then you would just flip that and go in the reverse direction. It just depends on how you mount your gauge head. We can do a hold velocity function right here, so you can hold it like if there's some issues where we need to hold the velocity, like over porous materials, or if it's like water spraying and they're breaking the laser beam, you can set that to hold if over above, and then you have to set this to hold last reading, and it'll read the last good reading until something bad falls in there. So that's just more extreme cases. Here's your calibration trim. You always want that to be 100. unless you're having to mount the gauge at an angle, like sometimes we do for like real shiny aluminum foil and stuff like that. So basically that's always 100% though. Contact your sales guy or service guy if think you might need to change that. The dip average is what our averaging time period that we're measuring. So basically some measurement points come in, some go out, like filling a bucket. We're doing a 32 millisecond average, dip average. You can lower that down to 1 millisecond if you want. The user update changes the user update for the actual display update. So you can see this unit can measure 999,000 feet per minute, plus or minus. There's where you can add extra material sensors into it if you want for doing like part lengths of like tubes and blank steel, stuff like that. So most of the time that's for tube length. You can put multiple different sensors in there to help keep the accuracy even better for overall part lengths. So starting from the beginning here, just shows you the model, the laser speed, your current temperatures and stuff like that. Your outputs, you can change the outputs to be different things, but this is basically the settings that you're going to want at the beginning. The laser speed settings as your baud rates, your Ethernet IP addresses and stuff like that, because this does have Ethernet IP built into it, as well as Profinet, so we can change all that. Once again, here's the standard settings. Mainly the things you're going to work with are the high speed, low speed pulse outputs. There's a fixed output that's always 5 volts, and then you can change the output to be 1,000 or 200 or 500 pulses per foot, whatever you want it to be. Then there's another one, there's a user scalable that's actually, it can be 5 to 28 volts, which could be wired into your pin 20 over here. You can bring in whatever voltage that your system needs. You can bring into pin 20. So say if you wanted 24 volts or pulses to be 24 volts, you wired into like pin 20 over here, and then that would go to that would make our pulse rates at 24 volts to be sent to your system. Another nice feature over here, I think it's pin number 10, is your material hold. So basically like on paper lines and stuff where the paper might flutter. And this would be more for like the 4000 series that does not measure forward and reverse and doesn't get past the nulling out of the vibration. That can hold your velocity if your line is just stopped and just sitting there. So you can see on the back of here we have Ethernet, that's Ethernet IP. We have Profibus, the 25 pin connector. This is nitrogen purge, so this actually puts a vacuum. We actually have a positive pressure of nitrogen inside of this unit, all sealed up. Here's water cooling if needed. Most people would never ever need that. So call if you have any questions. Thanks. All right, I also wanted to show you the Data Pro 700 display right here. And this will show, you can see how it can move, and it shows you the speed and the footage on there. Your quality factor is a nice little bar down here. You can see when I block the laser beam that it goes away. So it's a nice indication to your operator that's not measuring the product properly. So, and you can see, it ramps up real fast in speed. Here's a few other displays you can do. You can look at length, cumulative length. You can reset either one of those. This accumulated length you can use for the full day, and then this one will just reset length on the top. So that's kind of nice. Here it gives you a little bit more interfacing of the valid measurements and stuff like that. Here's a little graphical display. Length countdown. So if you do have a length value you're looking to get into, when it hits that length value, it's going to restart at 0 again. So here's for part length if you're measuring tube lengths or sheet lengths. And that's the main screen that most people use. So once again, you can choose either this one or the PC software. They use both the same serial communications. So hopefully that's helpful. Another key characteristic when setting these up, you want this face to be parallel with the product surface face. You can tilt this in the fashion of where if you're looking at lights, it can lean towards you or away from you, but you don't want to angle it this way, or you don't want to twist it this way or this way. You want to kind of keep the product in line with this edge moving in fashion of the housing, this fashion. So keep this parallel and this parallel, and you'll be perfect for mounting. Thanks.